Hey guys, what's up? Eddie Aho here with KissAnalog.com. Today we're back with the Spectrum Analyzer. Gotta use it while I have it, right? We're gonna look at a Class D amplifier. We're gonna sniff around. I'm gonna show you what. Hey look, there's some noise. Can you see the spikes from there? Alright, so what I'm doing is I got this probe. This is what we call a near field probe because I'm near the field. You probe around your circuit, you're near the field, near field. Far field is when you're like in a large chamber, you're at open air site, they call them, and you're doing EMI testing for compliance. This is what we call pre-compliance. This kind of gives you an idea if you have like some huge spike. Now, what can happen is, let's say you're at a far field EMI test facility and you're testing and you see some stuff. Well, that stuff you see, you would see it with this too. You would see it in your near field testing. Now the thing is, you might be doing near field testing and you see something that scares you. You spend all this time trying to solve it, and then you go to the far field and you don't see it. It's not a problem. So that can happen. But whenever there's a problem in far field, you should be able to spot it at near field. So, you know, the near field testing just takes some practice, kind of playing around, looking at things. Now, it's near field, right? So we're close to the circuit. We're probing around the circuit, looking to see if we pick up some, in this case, magnetic field. There's also a voltage field, and it's a little bit different probe. Now, I got these two probes. I got a couple little probes here. Got this little antenna too. But, yeah, I bought a few things for this, but I've got another kit of these guys coming. And when they come, I'll do a video on the probes and do a little more explanation on that. Today, what we're going to do is we're going to use this near field probe, and this is like what we call the H field, okay? And the voltage field would be the E field. And this one's a good one to start with, the magnetic field. So I had these guys, you know, here, and I'm getting some more. And by the way, look at all the coupling. It might not look like a lot there, but there's 2, 4, 6 connections. That's not a great thing. So when we have all this kind of coupling that, you know, as long as we're getting a signal, I think that's probably okay. What we're doing is we're getting a relative measurement, you know, just kind of getting relative thing. Now, if you have a bad connection, your relative connections might be terrible. When I first started this, I had a different cable, and I wasn't seeing anything. So I put this guy, now I have a nice stiff cable that I don't need all the connections for, but it's stiff and it's short, it's hard to move around. This cable's nice and small. The thing with these RF, you know, testing devices, you have these end connectors, you know, for Nancy, and they're large, you know. And then we normally have the BNC connectors on the scopes. Well, there's N to BNC. But the other RF connector that's real common is these little SMA connectors, okay? We got the male side here, the threaded male side here. So it's got to go on the female side. So you got 2 types of SMA connectors, trying to make sure that's tight. And then you have your BNC connectors, 2 types, male, female, and your end connectors, male and female. So you got 6 different mating types. And like on this cable, I got an end connector on one side and on the other side SMA. But it's the wrong one to go with this probe. They're both females. So, yeah, what I should do is get one of these cables that has the male, so it'll connect directly into this and get rid of all these connections. I only have 2 instead of 6. So just to let you know, you run into that kind of thing. That's why you may have, in earlier videos when I was kind of showing, getting you familiar with how this thing works, you saw this big old kit, and you're wondering like, well, why did I spend all the money for that? Well, because there's all kinds of different connections, and there's some here too. So first I bought these and I thought, oh shoot, I better buy the kit because I don't want to be doing a video and need something I don't have. So there you go. And I got a couple more cables down here. But yeah, you just end up with stuff like this. So we're doing relative measurements. So let's go jump into this. And this Class D amp, here, I'll stick that right there. Look at that. Starting to see spikes coming up. It's kind of going across here slow because I got pretty small bandwidth resolution. And here, let me show you. All right, so here's the Class D amp, okay? It's not quite done. I took it to friends, we listened to it, we liked it, but I got to finish it up now, okay? I've got some probes here you can see. These are differential probes, some mixed sigs, and there's a mixed sig scope, and look at that, there's the signals right there, left and right channel, okay? So I've got, here, let me come over here. I've got this generator, the Uni-T, okay? And it's coming over here and it's going into both inputs. I got them paralleled. And so the output's coming to these resistors, which are getting really hot already. And I've got two more in between. The bottom one and top one are 8 ohms. The middle ones are 4 ohms, but I just kind of all stacked up. The 8 ohms are connected, the 4 ohms are not, but it's heating up the 4 ohms. They're acting like heat sinks to help keep that thing cool. So that just kind of helps keep everything cool, stack them together like that. And there we go. So let me just kind of walk you through this guy here. Here's the AC input. It comes in. One comes up to this switch here, one of the conductors, the line conductor, comes back here and then goes to the board right down here, okay? Then you see we have a fuse, EMI filter right here, and it goes to, there's comm mode choke, bridge rectifier, bulk capacitors, some filter caps here, and then we come into our voltage conversion for the Class D amp, okay? Now that's an interesting heat sink, right? So we got this big heat sink. The middle part goes down on the board where we have our surface mount FETs that are switching, and they could be GAN for all I know, but anyway, we have our output chokes for each Class D for left and right channel. So that's a really cool, interesting heatsink they came up with, as well as the bulk capacitors here. And here's our transformer for our isolated voltage conversion. And I just laid that there like that, okay? What I'm going to do is I'm going to go around and sniff things out. They call it sniffing out the circuit. So we'll do that, and I'll have this camera here, and I'll put the other camera on the screen so you can see the screen a little bit better, okay? And then we're going to zoom in on these peaks and get a better look at what they look like. And it gives you an idea where the noise is coming from. And like I said, it's relative, so we're looking at this and we can see how high they are. We'll look other places and see if we see anything relatively higher, relatively lower, just to kind of give an idea. Now that transformer, we would expect to see some signals coming off, and we do. But now we'll look around the circuit and see what else we see. Like, for instance, the output cables or input cables. So there you go. Let me know what you think about using a little GoPro camera. That's a camera I've had around for a little bit. It's really wide angle, so it's probably distorted. Anyway, it's easier than moving the camera back and forth, I think. And I'm still going to bring that camera over here to look at the screen. Maybe I can zoom from there, I don't know. But anyway, so I still need to use both cameras, so that way you can see the screen at the same time you can see where I'm probing around on the circuit. Alright? It ought to be fun, right? This give you an idea what a spectrum can do and what those probes, those sniffer probes can do. So, yeah, it's kind of a fun thing. We get a look at the Class D amp. Same time we get to see how the spectrum works. So let's do this thing. Okay guys, so what I did is I hit this default, start over. I wanted to show you how we're going to just kind of search for a signal. Now this is out to 2 gigahertz and it's all the way down to, well, hold on, it says it started at 10 meg. That's interesting. I thought it would have gone down to the minimum. So you know what, I'm going to go ahead and do that. Start at 10K, not 9K, but just make it even 10K. So, alright, so it looks like most of the noise is down in this first grid for sure. So each grid is, there's 10 grids, 2 gigahertz, 2.1, so roughly 200 megahertz per grid. So let's shrink it down to about half that grid. That's where it looks like most of the noise is. Okay, so we're going to go stop at 10 meg, right? Okay, stop 10 megahertz. Yeah, there we go. Looks like there's something maybe down here by 10K, but it looks like the highest ones are here. I guess if we go to peak marker and let it find it for us, peak search. Okay, so right here, 6.8 megahertz. It looks like they're, if I leave this peak search on, it kind of bounces around. So it looks like a bunch of those are the highest ones, right around 6 meg. So let's do center frequency. Now, here, I can show you one thing we could do is I'm going to turn off this continuous peak search thing. And what I'll do is I'll say, okay, we're going to search to center the screen on that marker. Okay, so what we do is go marker, CF step, and then go marker and hit this marker and say center frequency right there. I think that's how you do it. Seems like a lot of steps. Would have been just easier to type in 6.4, 6.5 meg. All right, so we're sitting right there in the middle of the screen. It looks like most of the noise is between here. And we've got a stop frequency of about 11.5. So we've got about 1 meg per. So that's like 2 meg. So let's do about half that. Let's do a span of 1 megahertz. So span 1 megahertz. There we go. So those are the highest peaks. There's not a lot of definition to them. That's our bandwidth. We're at 10 kilohertz. I'm not sure why the auto doesn't try to give you a better picture, but I don't know how it would do it. I guess it'd be based on how much time you want to wait for a screen scan, maybe. So there's 300 hertz. And look at all that stuff that just appeared. If I go back up, all that stuff gets averaged in. Like at 10 kilohertz, 10 kilohertz width gets all added together and averaged to one bump. But if we go 3 kilohertz, we get more resolution. Every 3 kilohertz gets averaged. There's 1 kilohertz. And look, more stuff is sticking out. So what I want to do, I'm going to go to the span. I'm going to spread things out a little bit, okay? But I think I see a pattern that I want to point out to you without losing it here. Okay, yeah. Here, I'm going to freeze it to make it more obvious. You see these higher peaks right here? The ones in between look the same. So at first when I saw it, I was like, oh, okay, here's a frequency. Here's a harmonic, and here's our harmonic from that one. And then this peak's a harmonic from that one, which it could be. But the other thing I notice is these taller ones, they look similar, that they have 2 short guys next to them and then 2 taller guys the next, bump over. Where the ones in between, the next ones that are next to it, the ones going away from it goes shorter, 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 versus this one goes short, tall, short. So I see that as a cyclic thing between these tall ones, and the ones in between look the same as well. So we either have a frequency of this, which is a harmonic of this one, which is a harmonic of this one, or these are all harmonics of each other. So there's either 2 different frequencies there, which would be kind of, if that's the case, they're just, 2x of each other, which is interesting. So chances are these are all harmonics, but it's interesting that the ones in between add. Anyway, I'm not sure what to make of that yet. So what I want to do is I want to focus on one of these guys, okay? Because the distance between all these little guys look the same from one point to the next. And I think I understand why that is. So let me just take the center. I'm just going to use this wheel to put in the middle. I could, do other fancy stuff, but that's just easy. Okay, then the span, I'm going to just stretch out again. Actually, that's going to take a while, so I'm going to just punch in. I'm going to try 100K. Sometimes that's faster. I'm waiting for an update, and it's not coming. What's going on? Let's go to bandwidth. It's 1K. What happened? It's like the screen froze or something. I'm not sure what's going on. Oh, yeah, sorry. I froze the screen. It's like, it's all digitized because let's let it redraw. Okay, there we go. Wow, that was weird. That was just me. Okay, resolution bandwidth of 1 kilohertz now. So each one of those points, I'll stop it again. If there were 2 frequencies in there, we wouldn't see them if there were only 1 kilohertz, within 1 kilohertz. So I don't think we're going to see anything in between, but let's just get a little more resolution to see. Yeah, it looks like, well, maybe. I almost see like 2 frequencies next to each other there, maybe. But each one of these guys are spaced the same distance. So let's see what that is. I think I know what it is. See if I can show it to you. Let's go to peak and go peak search. Okay, there's that guy. And then let's go to marker and we'll go marker delta. Okay, and then back to peak and then next peak. There's no valid peak. Huh. Looks like there's peaks to me. What the heck? Not sure why that's... Okay, here. Oh, okay. If I hit the next peak to the right, it found it. Maybe, I don't know what the deal was. Maybe the other peaks, there's too many of them, the same amplitude. So it didn't know which one to find. I don't know. Okay, so if I go next peak to the right, it finds it. And it's 10 kilohertz. It's 10.1. Now, if I did the resolution and all that stuff, I think it'd end up being 10 kilohertz. And that's from the... Okay, guys, had a problem there with the memory card. So we're back, and I'm not sure where I left off the screen because I might have reset it. But I think that's where we were. Here, let me stop this thing for a minute so it stops jumping around. And we have 10.9 kilohertz between... Well, and it's kind of, this peak's kind of moved. It should be 10 kilohertz. Okay, that says 900 hertz. So yeah, see, we're 900 hertz off. If I go to the next peak over, 10.9. So it's actually 10 kilohertz between those peaks. So that's from the generator, the signal I'm putting into the Class D amp. So here, let me just, you'll be able to tell. I'm going to change the frequency to... I'm going to drop it down. Let's go down. There's 9, 8. You're going to see those things come in a little closer as the frequency gets smaller because now it's crowded. So I'm down at 1 kilohertz. So that's what it looks like at 1K. So let's go ahead and spread it out. Whoops. Let's go to frequency. Span 100K. Let's go to 10K. And let's see. Yeah, because that looks pretty bad. My frequency, see if I move this at 2 kilohertz, you see it's starting to spread away from each other, that frequency. But yeah, instead of spikes, we're just seeing this kind of mess. Bandwidth, wow. Usually you can go slower bandwidth, it looks cleaner, but yeah, just not seeing it. So, okay. So what I'm going to do, that's 100 hertz bandwidth. What I'm going to do is go to span and bring these guys in a little bit. We're up around 10K. Let's see what that looks like. Here, I'll do 20K. Okay, so those are those frequency bands that as I change my frequency, if I go higher frequency, they go further away because there's more, there's more frequency between them. But if I go down, they come together. I want to do start frequency at 10K. I want to try to see if I can find one of these notches at a lower frequency down here instead of out here at 6 meg. See, this 10K, we're coming out here to 6.5 meg. We're looking at a frequency right here and we're spreading it out. I want to come over here and spread out one of these, okay? So that's 10K. It's probably about 1 meg right in here. So we're going to do a span of 1 meg. Or stop. Let's go stop frequency 1 meg. Yeah, there we go. So what I want to do is I want to get this guy, this first guy, I think. Let's find what peak that is. Okay. That's a... What the heck? Oh, you know what? It says 6.4 megahertz. That's because it's a change of marker, that little delta symbol. So I have to come over here in my markers and I have to say all markers off. So I got to start over. Okay. So now go to peak and go peak search. There we go. So I got a nice clean number 189.2K. All right. So you know what? That's the frequency we see between each set of these is 89.2, around 89K. So, and then between the ones that kind of look like each other, it's just twice that frequency. And same thing here. I see the 3 bumps. That looks similar to this one, although it's lower, you know, they're lower amplitude. Looks similar to this one. The ones in between kind of look similar. But I want to go this 89K is my center frequency. Okay, 89.2. So I want to go center 89.2 kilohertz. There it is, and there's those sidebands. So now if I bring my frequency up, you see them separate, and as I bring them to smaller, like 1 kilohertz, you see them come closer together. I'm going to put them at 1 kilohertz, kind of close together right now, and I want to make this span. See, if I make 2 kilohertz, I'd have 1 peak here and 1 peak here in the center peak. And let's just do that just to see if that's true. 2K. It looks really bad again. Let's see if this bandwidth is going to help me on this one. Okay, there we go. Now look, now we're getting a bunch of other stuff in here. So, but we are getting a lot cleaner picture. Here, I'm going to go back up. We'll come down to the lower. Yeah, I'm going to stay at 10 hertz. So we see all these bumps. But what I want to do is come to my span and go to 4K. Just so if we can see those. Yeah, there we go. There's our 1 kilohertz here and our 1 kilohertz here. Okay. The center, I'm going to roll that right over there. And see, my span is 4K. So this is 4K, 2K's in the middle, and 2K's in the middle. And then we'll have 2K, 3K, 4K. So that's 1K from this guy and this 1K from this side here. Okay? But now look at this stuff. What the heck is that stuff? So that's one nice thing. I couldn't do that at 6 meg, but down here I can. So let's zero in on that. Go to bandwidth. Well, before I do that, I want to zoom in on it. So instead of 4K, let's just stretch it out this way, I guess. Lots of turns. That's why they put that little hole there. Finger dial. All right. Now what is all that stuff? I'm going to try to do it so they line up on these grids. So to make measuring them really easy. I'm kind of off to the right a little bit on the center one. So there we go. And look at that. So I got them dialed in so they're just about on grids of each other. And so I'm at 1.2 kilohertz straight across. Well, we can use our markers to measure it, but we'll use our bandwidth to get a little bit cleaner bandwidth, 3 hertz. Well, I think it'll go down 1 hertz. This guy's pretty nice. It does have a 1 hertz resolution, and you can see how long it's taking to come across. There's a little green arrow here at the bottom of the screen that's hard to see. And it's just coming across. Okay, there it goes. You can see it. Okay. Wow. So what are those? What do you think? Let's go to peak. Let's go peak search. Okay. So right there, 89.28K. And then let's go find the next one. So let's do the marker and delta again and back to peak. And let's go to the next peak. Next peak over says 125 hertz. And that's because every time it scans, it puts it in a slightly different spot. So if I go back to the left, it's 7 hertz off. So 7 hertz minus this, 127 minus the 7, it's 120 hertz. So just thought you'd think that was interesting. That's the 120 hertz coming from the power supply, the bridge rectifier. And these things are down around minus 50 dB. Wow. So Isn't that crazy? You can find the high frequency stuff and the low frequency stuff. You just have to dig for it. So, whew, okay, I think that's enough for this video. Oy. Hey guys, I hope that was interesting. I was kind of, you're kind of like looking at it with me for the first time too, so I didn't really have anything scripted to show you exactly what we're looking at. I just wanted to kind of jump in there and look around. But it's interesting how you could see the 120 hertz even to 60 hertz. There's not a PFC on this guy, which is disappointing. A lot of times you'll see these LLC converters, providing the isolation and the voltage for the Class D. But it's too bad, because I've looked for power supplies to run some of these Class D amps I have, and even the higher power ones, which I thought for sure would come with active, with active PFC. But God, it's crazy. I'm surprised that they don't. Anyway, yeah, if you guys know of a PFC feeding 1,000 watt or 600 watt, converter with a nice voltage for these Class Ds, let me know. But anyway, yeah, I just wanted to kind of show you how you could kind of sniff around the circuit and look for things. And, just without an agenda or anything, just kind of looking around and seeing what we see. So let me know what you guys think. Give me your comments down below. Appreciate that. And thanks to the patrons. Really appreciate you guys. And thanks for anybody that's hitting that thank you button down below that YouTube added. That's really nice too. And appreciate all your support. And I'll do some more videos with this Spectrum, see what else we can see. I'll pull out a PFC converter and see if we can watch that too. Alright, maybe compare that to a regular power supply, a low frequency switcher. Let me know what you guys think, and appreciate you watching. See you next time.